Now, we've already seen in a previous video that the area under a graph is given by the integral of y dx. This is the graph of y equals x squared, and this video is going to show how we can work out the area of this graph between 1 and 2. Whereas previously we've done indefinite integration, this is a definite integration. We actually definitely want to know the answer for the area between 1 and 2. And so those limits 1 and 2 are put on the integral sign. 1 and 2. So what is y? Well, we know what y is. It's x squared. So it's the integral from 1 to 2 of x squared dx. Now, integration is the inverse of differentiation. So what we need to do is to find what function differentiates to make x squared, and that's a third x cubed plus c. What we're going to do is we're going to find out the actual area, and at this point we put in square brackets and we put the limits 1 and 2. 1 and 2. Now we're going to work out, we're going to substitute the values 1 and 2 into that expression. So it's a third times 2 cubed plus c minus a third times 1 cubed plus c. Now working out a third times 2 cubed plus c is actually working out the whole area from 2 to 0. Working out, putting in 1 here is working out the area from 0 to 1. We just want the bit between 1 and 2, so that's why we put in 2, we put in 1, subtract 1 from the other. Putting in 2 gives us the whole area. Putting in 1 just gives us this area, so if you subtract them, you get the bit that's left. So this works out to be 8 over 3 plus c minus 1 over 3 minus c. It's minus because minus plus is minus. Notice that the c's are now going to cancel out, so really we didn't need to put them in. We didn't need to put in a plus c there because the c's were always going to cancel out. So the overall answer is 7 over 3. So whereas in indefinite integration, where we end up with an expression, an algebraic expression for the answer, with those we do need to put in the plus c. For a definite integration where we're getting an actual area, we don't need to put them in, so you don't need to bother putting in the plus c. In this question we want to find out the value of that red shaded area there. So it's y dx from 1 to 2, and the equation of this graph is y equals minus x squared. So what we need to do is to integrate minus x squared dx from 1 to 2. What function is it that differentiates to minus x squared? Well, it's minus a third x cubed. You may be able to see where this is going, but I'm going to carry on. Let's put in 2, so that's minus 2 cubed, that's 8 over 3. Take away minus 1 cubed over 3. So that's minus 8 over 3 plus 1 over 3, which is minus 7 over 3. Now this is either quite confusing or very powerful depending on your point of view. We're working out this area here and we've got a negative answer. An area cannot be negative. So this minus 7 thirds actually consists of two bits of information. The 7 thirds is the area, that's the area of that shape. It's a bit like a trapezium, but it's got a curvy bit there. And the minus sign tells us that it's underneath the x-axis. If a question says, what is this area? The area is 7 thirds. If a question asks for this integral, the answer is minus 7 thirds. So the 7 thirds tells you the size of that shape, and the minus sign shows that it's underneath the x-axis. Now things get more interesting when we have shapes like this. Here we've got two graphs. The equations of these graphs are y equals 6x plus 2 and y equals x squared plus 7. And we need to find the area between the two graphs. Now, the straightforward thing is to find the area here that I'm going to shade in blue. That area, which let's call this A, area A is the integral from 1 to 5 of x squared plus 7 dx. It's from 1 to 5 because that's 1 and that's 5. So I'll put in 1 and 5. So I need to integrate x squared, that's a third x cubed. I need to integrate 7, that's 7x. I need to substitute in 1 and 5. So that's 5 cubed over 3 plus 35 minus 1 cubed over 3 plus 7. And that works out to be 208 over 3. Now we need to work out area B, which is this trapezium here. So area B is the area of that trapezium, and there's two ways of doing this. One way of doing this is to do the integral of 6x plus 2 from x equals 1 to 5. So if you integrate 6x, that's 3x squared. Integrate 2, that's 2x, and it's from 1 to 5. Put in 5, put in 1, and we get 80. Now an alternative way of doing this, which I happen to like, but most people don't, is to work out the area of the trapezium. The height here we can see is 8. The height here we can see is 32. And the gap there is 4. So it's a half of the sum of the parallel sides, 8 plus 32, times by the height. So half of 4 is 2, 2 times 40 equals 80. So we've got the same answer in two ways. So the whole area B equals 80. So the actual answer that the answer to the question that we want, which is the red area here, it's B minus A. So that's 80 minus 208 over 3, which is 32 over 3.